linear regression model, the first model that we have studied is a straight line. The same model is what we are that format only, a similar model only, the mathematics for that as well as the multiple and multivariate regression, it is a similar model. So a continuation of that only we are going to see today. So the f of x is a straight line, and what are the variables involved? What is the terminology used for telling these variables? How do you call them? How do you actually represent them in ML terms? That's what we are going to see. If you remember, we started with data points. So you had an X and Y value for each data point. So you can call them as N observations. You no longer call them as simply data points. You can also call them as observations. They are sample points, samples. All of these are interchangeably used. Popularly used is observations. So every data point is an observation for a given problem. For example, if the age is 25, what is the glucose level? If the age is 75, what is the glucose level? There might be so many other factors which are relevant to this context. For example, does that person already have diabetes or not? Blood pressure or not? Any other complications? So disease or lung disease or even brain disease. Okay, so let us take a list of patients and then check the glucose level. Only the glucose level details we have seen as a data point. Actually speaking, if the data point is a two-dimensional data point, so in the x-axis you take age of the patient. Why always age of the patient will be given? The glucose level you might know or you may not know. If you don't know, you can actually predict based on the other patients. For example, if a 20-year-old has the glucose level at 100, if 50-year-old the glucose level is 120, somebody in between might have a glucose level between 100 and 120. So a 35-year-old may have glucose level between 100 and 120. Is it so? Actually, that is what we are answering by using the regression line. The line is going to tell what is the trend. So if this is the age, a point, the corresponding point, the x value is age. The corresponding y value for that x, that will be which is staying on the line, which is on the line, could be the assumption you can make or predict. It's not an assumption anymore, you call it as prediction. So the observation is age and glucose level in the current asset we are discussing, what we saw yesterday. And prediction. So what are you predicting? You are predicting y. Or x, you call it as it's actually a variable. This is x and y are dependent and independent variables. One of them is a dependent variable, another one is an independent variable. For example, age is independent variable, but those are dependent. And what do you usually predict? Age is given and you predict the glucose level. So you also have another term is a predictor. Therefore, x is the predictor variable. Y, the glucose level, is the response variable. And the glucose level is also a dependent variable. So this is the terminology used in a regression model context. In general, this is how it will be. We will see how, in general, how it will be. We will see. That is the examples we are going to see further. So let us, in this context, simple regression context itself, let us define how we will no longer call it as slope and y-intercept. We will simply say they are parameters. So y is equal to beta naught, beta 0 plus beta 1 into xi plus epsilon. Epsilon is some error. What is that error? It is the value for every data point. That's why it is given yi is equal to beta 0 plus beta 1 into xi plus epsilon I. Why it is I? Because it is the first data point, second data point, third data point. The error represents the distance, vertical distance of this data point with the regression line. Okay. So the parameters are beta naught and beta 1. You no longer call them as mx plus c. You will call them as parameters b naught, beta naught, and beta 1. We are not going to calculate statistically. For us, it is now the machine learning perspective. In the context of machine learning, these two are just parameters. We assume a value for them initially, and by reducing the error, we try to reduce the error through iteration as the training or the learning process. Okay, the learning process includes training and testing and validation. 3 steps are there. In the we saw yesterday, testing is we will see from the exam only. We will see how do you do the testing, how do you do validation. Now, once you fix it, is simply yi is equal to, assuming that the error is too low, you ignore the error. So once the learning or the training is over, the error is negligible and you can ignore that. So you call this as the fit model. Yi is equal to beta naught beta 1 x, whichever was. Now you can equate that to the statistical value. Actually, statistically, this is how you get the parameters, right? Beta 1 is the slope. We saw this yesterday. And beta 0 is the y-intercept. And this estimated parameters, whatever by machine learning, whatever you estimated, the value for beta 1 and beta naught, actually it is equal to this formula, this equation. You can substitute that in this equation. So in most applications, the error term, which the error term that you have epsilon. Okay, if take x and the random variable x takes the values x1, x2, x3 till xn. Y takes the values y1, y2, y3 till yn. So there are 2 random variables. Since y and x is a random variable, epsilon, the error is also a random variable. So if it is a random variable, the values that it can take forms a probability distribution. So the error term epsilon, it is also a random variability distribution, can be treated to be a normal distribution, the bell curve. Okay, and because this is independent of x and y, the error, you cannot say this is the value of x, this is the value of y. Because of that, the error is this, we cannot say. Therefore, error is actually independent of x and y. They are random variables, and therefore you can generally use a normal. And this is what you call it as a model. This equation is what you call it as a model. Error after the training or after the learning process is over, you call this as the model fitting. This is what you mean by model fitting. So I hope this is clear. Any questions on this? In normal distribution, so what is given here is n of 0 comma sigma square, where sigma is actually the variance. And we know how this thing can actually differ. We definitely have heard of it before. So that details are. The next one is about multiple regression. So when not plus beta 1 x, right? So you just have one x term here. Instead of one x term, you can have multiple x terms. So it could be, so you can write it in the matrix form also, because you know x1, x2, x3, x4, let's say 4 variables you have, and y is equal to beta 1 into x1 plus beta 2 into x2 plus beta 3 into x3 plus beta 4 into x4 plus beta naught plus epsilon. That's what you see here. So this can be summarized into, that beta naught can be summarized as 1 into beta, x equal to 1. You can take it as x equal to 1. Therefore, for every y1, y2, y3, y1 equal beta naught 1 into beta naught plus beta 1 into x11 plus beta 2 into x12 plus beta q into xq. So the number of, if it is just 4, then you can simply say beta 4 into x1 4. Q is 4. You can take it like that. So like this, you can actually reference in how many values of x and y were there. In our example yesterday, one example we had only 6 values. Another example we had at 12 values, around 10 to 12 values we had. So you will have y1, y2, y3 till y6 for one example and for another example. So all this has been put together in a matrix form, and therefore y is equal to x, y matrix is equal to x matrix into beta matrix plus epsilon matrix. So this is multiple regression. So the parameter is 4 parameters, 1, 2, 3, 4. Then it is 0, 1, 2, 3, 4. That many parameters from examples. We don't call it examples, we call them as observations or samples or data points. Now what is linear regression? Y itself is going to be so many for a single equation. Y itself is going to be more than 1. Therefore, you will have beta also, a 2-dimensional. So y is a 2-dimensional matrix and beta therefore is also a 2-dimensional matrix. Okay, so that is this is something we will go next. But multiple regression is something that we should try to understand before we go for multivariate regression. Now, how will you justify beta 1, 2, 3, 4? Let us take just 4. So in the same case where we said, the age of a patient is x1, and the glucose level is y1, right? Y. Now, age of the patient alone does not determine the glucose level. Therefore, x2 can be x1, x2, x3, x4. So we are going to consider now 4 factors. they will be predictors. All the four will be predictor variables only, independent variables. We consider them to be independent variables. Whether there is a dependency or not, the machine learning process will expose. So say X1 is age, X2 is diabetes, yes or no, X3 is heart disease, yes or no, X4 is, some other disease, yes or no. Pressure, blood pressure, yes or no, or the pressure value is so much. What is the blood pressure value? Diabetes, yes or no, heart disease, yes or no, and blood pressure, give the blood pressure value itself, whatever is the pressure of the patient. So therefore you have age, diabetes, yes or no, heart disease, yes or no, and the fourth one is the blood pressure value. So now these four factors together, how they are going to affect or influence the glucose level of a patient. That is the study that we will do using a regression line. Any questions here, please?
No, ma'am.
No questions?
No, ma'am.
No, ma'am.
Okay, is it clear? You have understood this? So in the context of a disease prediction, for example, now the glucose level is a prediction. That's what we have taken here. I mean, that's what we are going to predict. That is a response variable. Now, the dependent variable. Now, what you want to predict, depending on that, your factors will change. So let us say you want to predict you have COVID, a patient has COVID or not, COVID-19 positive or not. So what are the factors involved? What are all the tests involved? What values will you consider to quantify that he has a COVID-19 positive or negative, whatever? So if your question is whether he has COVID, he is COVID positive or not, he or she, the patient is COVID positive or not. So how many factors are you going to consider? In general, if you go into a hospital, there will be so many factors that they consider. So all of them will form this X1, X2, X3, X4. Some combinations, they are not very sure about COVID-19 positive, but then they are able to infer something else. So the inference that you're getting is that is what is your, that will be for the Y variable. Regarding glucose level, you will be inferring from the factors, the rest of the factors. Likewise, regarding COVID-19 positive, you can get inference from, I mean, you will make inference from the data that you get on the factors. For every patient, you will do that. So in general, that is how expert is built. Human expertise is also built like that. An architect builds 100 buildings, he has now a general idea. For so many situations, he knows how this has to be handled. For any challenge, he knows how it has to be handled, how he has done it before. From that, he gets an insight, he makes an inference. If this is the case, it can be handled like this, or you can even try out something else like this. So there can be new challenges. You sharing that experience is what you mean by from more than one in, then you just not have one y, you have y1, y2, y3. So let us say you have two inferences you're making. One is COVID-19, the other one is glucose level. Both inferences you want to make, you want to find out, you want to answer from the four factors we are considering. So then you have y1, y2, and all cross combinations you will have. So x1, x2, x3, x4, y1, y2. So how x1, x2, x3, x4 actually influences y1 only, influences y2 only, influences both combinations, right? Both of them, both combinations also should be seen. So what is the that doesn't become multiple regression. That is when it becomes multivariate regression. And most of the time, multivariate regression is also very common, right? Multiple regression and multivariate regression are very common. Single or simple regression is not common at all. Actually, it is not common at all. You always have so many factors influencing a particular conclusion. So I would say whatever you're predicting, that is the conclusion in this context. So the conclusion is about glucose level. The conclusion is about COVID-19 positive. In only one conclusion you're considering at a time. So you could use either simple regression or you could use multiple regression. But if you want to make more than one conclusion, then you have to go for a multivariate regression. Okay, so now this multiple conclusions, it is very common. It is very common. So how do you calculate that? How do you go about that? So if we consider a data set, we can first solve for, we can do a calculation for multiple regression first and then go for multivariate regression. So we should be focusing on multiple regression. So for one more session, we will focus on multiple regression, and we will look at different data set examples. The same UCI machine learning repository data set, whatever you have considered or whatever you have downloaded, if one of you can that you have downloaded, we can discuss that data set for multiple regression. Is that possible?
Fine, ma'am.
So one of you please share the dataset you downloaded and show me the attributes, the column attributes in the dataset.
Yes, ma'am. Sharing. Are you able to see it now?
I can see it.
Okay, ma'am. This is a bicycle data set, ma'am. Daily rental of a bicycle, bike sharing.
Okay.
So it's like instant is given, date is given, the season is given, year, month, holiday, temperature at
So
that
what
particular
is
time.
so what is the what inferences can you make out of this data set? You can keep it shared. Just keep it shared. Okay. So what inferences can we make out of this data set? Actually, it is conveying something to us. If you look at the last column, count, how many registered, the casual, what is this wind speed? Oh, wind speed, humidity, temperature. Huh? Is that so?
Yes, ma'am. Yes, ma'am.
Okay. Okay. So from this data, actually, in a specific weather condition, what is the demand? How many people actually took the bicycles in specific weather conditions, and during weekdays, working days, and weekends, holidays? So monthly, how much is the demand? Yearly, how much is the demand? These are inferences that you can make from this data set. Now, if you have to automate the answer for this question, data set is given. See, explicitly these things are listed out. That's what you mean by a data set. So every instance is actually a data point or an observation. So in this case, how many x's and how many y's you are having is dependent on what is the question you want to answer. You just want to answer in a specific weather condition, what is the demand, which means you should already know for different weather conditions. For every weather condition, what is the demand if you know. For any specific weather condition, what is the demand you can actually predict also. You can answer that question. So which means out of all the variables here, you just need to take the weather condition variable, maybe the ith column. You can also take the cth column if it will be useful. In this, have so many ones. Yeah, that one, the season column. It's really, you know what it. Whether
Ma'am,
I.
there are 4 seasons of the year, like summer, winter, autumn, spring.
Okay, so we can consider that. So consider the ith column which talks about the weather.
Weather is like, ma'am, sunny, windy. Like,
However,
that's 1, 2, 3, 4 is like indicating it's sunny, windy, rainy, or like something like that.
so how specific is your question? Accordingly, you can choose your variables. These are the X variables which can help you predict. So they are called as the predictors. So the predictor variable would be season and weather. Let's just take these two. For it is X1. What is it that you want to predict? The count, the P column. So in this particular question, for this particular question, you only have X1, X2 and one Y1. So this is your response variable. That is count. Count is your response variable, and X1 is your season. X2 is your weather condition, sunny, windy, rainy, right? So these two variables and this. Now you are a model for that. Fitting you will do, and then finally you will create a regression um, uh, plane. Since it x1 is x2 is another axis and the y is the third axis, though it's three-dimensional, it will not be a regression line. Multiple regression would be beta naught plus beta 1 x1 plus beta 2 x2 plus some epsilon. So the three dimensions means, you know, x1 and x2 together will make a plane. So it was a line, dimensional plane kind of structure you will have for regression. So that's how your visualize beyond three dimensions. Actually take exactly the same data set, you know, you have how many x's the day, right? B, if you expand B a little bit, you can see the data, right? It is all showing hash now. Narayanan,
Yes,
can
ma'am.
you expand this column, B column, make it wider? Do
Actually,
it
it's
here.
showing in this year, ma'am. It's actually the date, ma'am. So 2/1/2011, 4/1/2000.
Yeah, just expand it a little.
It's not.
It's not expand. No, expand means. No, you are not able to. No,
No, ma'am. It's
not
not.
like to
Editing
choose
is not.
only.
Editing is not enabled now. I'll just put it in one Google Sheets one. Google Sheets I'll put this time.
No, it's okay. I think it's fine. I think it's fine. So the date is not going to help us basically in this context. But if you have more specific questions like from this date to this, for example, the second week of April every year, I want to know what will be the demand. Second week of April. So if that is the case, you can take the date variable also you can consider. Otherwise, if you consider everything, how many variables you have? B, C, D, E, F, G, H, I, J, K, L, M, N. N. Actually, N variables you have. So you have x1, x2, x3, x4 till xn. So it is a n plus 1 dimensional space. Now y is just p. Now how many registered and how many took? How many registered and how many took? Regarding this, if you have a question, then you should consider column O also. This is how we consider and build a regression line. Is that clear? I thank you, Narayan. Thank you. You can unshare the screen. Is that fine? Multiple regression. So let us take a data set, and then I have shared the Python notebook with you. You can use Narayan can use this particular data set. You can play with selecting the columns, and then the multiple regression formula and code is available in Python in the Python notebook. I suggest that you test this data set for multiple regression with that example. In the next class, we will just look at a worked out calculation example for regression. So one example for multiple regression if you do, after that multivariate also we can see one example. With that we will close regression. But it would be interesting to see what kind of advanced applications you can use regression. That will also be an interesting aspect for us to explore, and we will do that. So I'm stopping the class for today. We will continue in the next class. Any questions if you have, you can ask me.
Ma'am, multiple regression means like multiple variables will be in the input to predict a single output, and
Yes, yes,
multivariate means multiple outputs for multiple inputs.
yes.
Okay.
Exactly. These are situations we can come across. And a simple regression model might be very useful. So we will also look at such applications. Some examples we will see. Because, do you find it easy, the calculation for regression? Adit Balaji. Raj Singh. Ashwin.
Yes, ma'am.
Yes, ma'am.
Regression, you're finding regression easy?
Not easy, ma'am, but we are like
So please do the calculation in the assignment that I gave yesterday. And then if you're stuck somewhere, you need to let me know. Okay?
okay, ma'am.
Ashwin?